Welcome all. Today we are just going to see about the topic name called inform search. And in inform search, we are just going to see about two different types of inform search. One is best first search and another one is generate and test. Before going to that, what is meant by the inform search and uninformed search? So inform search, the search is we already the information is known to everyone. So the cost, information, distance, everything which is known to it, so that is said to be as an informed search. The other name of informed search, it is said to be as an heuristic search. So whenever we are just going to find the optimal path of a particular best solution, we know all the route, cost as well as the path. For that only the search is already known, the information is already known about it, so we can find out the we can find the information easily. So that is about the informed search. So what is about the uninformed search? Uninformed search, the information is not known, so it is said to be as a blind search. So for example, we have, if you are know the good example for uninformed search is BFS DFS. So since there are root node will be there, followed by the child nodes will be there. So each and every node that can be a traversal y through a neighborhood as well as to the depth, it is like a BFS as well as DFS, that is of breadth first search and depth first search. According to that, we'll be having of no information, that is said to be as an blind search. So moving to that, informed search, we already know about it. So it is an heuristic search. It's a strategy of for searching that is known about the knowledge about the problem to guide the search process towards the goal more efficiently. So in uninformed search method, we can explore the search space without any knowledge of where the goal might be. Informed search uses a heuristic to make a better decision about the path to explore next. So uninformed search techniques can require exploring a large number of nodes, leading to the high time and memory complexity. As the size and complexity of the problem increase, we can find the solution that can be computational expensive. So therefore, optimizing the searching process became a significant challenge for it. So while going for the informed search, that is often heuristic search, so there will be often some domain specific knowledge that can help how to determine how close to the particular state is in goal state. So by using the information which is already known about it, so we can prioritize promising path and avoid the unnecessary exploration of less relevant areas of the search space. So the effectiveness of the informed search can be depends on the quality of heuristic function used. So the primary objective of the informed search is to improve by reducing the number of states that need to be examined. So these are and all the strategies that can be used with the knowledge about the problem domain, the environment, as well as the characteristics of the goal to guide the search process. To move on it, as a result of the informed search algorithm can be find the optimal solution and faster than the uninformed search. So the common examples of uninformed search, that will be of breadth first search, depth first search, as well as uniform cost search. Apart from that, there will be of having a depth limited search, iterative searching, and deepening searching. Everything it is of without cost. There will be of having a no information on it. While moving to the common examples of informed search, that can be of treating with a greedy best first search algorithm, A star search algorithm, AO star search algorithm, and hill climbing search algorithm. Greedy best first search selects the node that can be appears close to the goal based on the heuristic value, whereas A star search combines the actual path cast and a heuristic estimate to find the efficient and often optimal solution. So these both algorithms are widely used in the technique of artificial intelligence applications, as we can find out the shortest route path, route planning, and robotics playing, game playing, and navigation system of it. So this is about the informed search. So as well as the good heuristic solutions can be find with the problem efficiently. Moving to the next slide. So as already we discussed about it, a heuristic function is the one that guides the decision of a selection of a path. So heuristic function h of n provides the estimate of the cost from the path from the given node to reach the goal state closer. So here there are the algorithms are there: generate and test, best first search, greedy best first search, A star search, and heuristics. So we'll be seeing about the generate and test and greedy best first search. So first we'll be going with the generate and test. So what is meant by generate and test? So it is one of the simplest problem solving and searching techniques used in the artificial intelligence. So the main objective is to use for generate and test is to repeatedly generate possible solutions and test each and every one to determine whether it satisfies the requirement of the problem. So the problem continues until a valid solution is found or all possible solutions have been examined. So this strategy will be very simple strategy. So according to that, it will be a first generate the possible solution. Second will be of testing the solution against the goal. If the solution satisfies all the requirements, accept the answer. If the solution does not satisfy the requirement, generate another possible solution and repeat the process. So the algorithm which can be represented as here. So do while goal not accomplished. So generate the possible solution, test the solution to see if it is a goal. So the explanation of this particular algorithm will be of the generation phase creates a candidate solution. The candidates may be produced randomly, systematically, or heuristic with the knowledge. So heuristic generally it helps to guide the generation process towards more promising solution, reducing the amount of unnecessary searching. Next will be of testing phase. Testing phase will be of evaluate whether the generator solution meets the expected or specified goal condition. If the candidate's solution failed to be tested, it has been discarded and another candidate is generated. If it is passes the test, the searches terminates successfully. And finally, generate and test is particularly used for finding the solution space is not extremely large and when it is very easy to verify whether the candidate solution is correct. So the common application which can be used for generate and test is a good example as traveling salesman problem, finding the shortest path node from wherever traversing from the root node to again the root node. The other examples will be of puzzle solving, game playing, theory proving, and simple optimization problem. So the advantage we can be used for generate and test will be of a very simple and easy for implementation, and it does not require complex reasoning or extensive domain knowledge. So the good example real time that can be used with crossword puzzle. The system may generate possible words of a blank space and test whether each word fits both the clue and intersecting letters. Similarly, in a route finding problem, so different paths can be generated and tested using a path loading the destination is found. Finally, generate and test is a straightforward searching strategy that solves the problem by producing the candidate solution as well as checking whether they have been satisfied with the desired goal decision. So next will be of generate and test. So already we have been explained about it. So it's an heuristic searching technique used in artificial intelligence, and here they will be of two ideas are there. One will be of generating the possible solution to the problem and testing whether each solution satisfies the goal condition. So the solution is acceptable, the search stops. Otherwise, the other solution is generated and tested. Moving to the algorithm, we already know about it. First is generate all the possible solutions, uh, or generating one possible solution at a time. Select a candidate solution from the set of possible solution. Test whether the solution selected which can be satisfies the goal requirement. If the solution is correct and acceptable, stop and return the solution. Otherwise, generate another solution and repeat the process. So working will be of it has been represented over here. Role of generator. The generator produces the possible solutions to the problem. It may generate solutions systematically, randomly, or by the heuristic value. So in a maze problem example, the generator creates a possible path from the start node to goal node. So next will be of tester. The tester checks whether the generated solution meets all the required condition. If the solution is correct, it is accepted as the final answer. If the solution is not correct, it is rejected and another solution will be repeated. The generator keeps on producing the candidate solution while the tester evaluates them. The cycle continues until a valid solution is found. So the main approach for using generating the solutions will be, one is generating the complete solution, generating the random solution. So generating the complete solution will be of complete solution will be generated first, and the tester can check whether it satisfies the goal. So the example, generating the entire route from the source to destination and checking if it is valid. Generating the random solution, solutions are generated randomly. Each and every generated solution is tested. The solution continues until the correct solution is found. Example will be of randomly guessing a password or checking whether if it is correct. So the good example will be of this, and advantages to is it's very easy and simple to implement, can be applied to many problem solving tasks. Disadvantage will be of very slow for large searching space and may require testing may incorrect solutions. So time complexity increases, the number of possible solutions grows. The example will be of square root of 25. So we'll be testing with the 3 cross 3 will be of 25. No. Generate another number. 5 cross 5 will be of 25. Yes. So 5 is accepted for the solution of it. So next we'll be moving to the example for it. So example, we can take it as a traveler salesman problem. So each and every traveler that needs to visit n cities. So know the distance between each and every pass of the cities, wants to find the shortest best path of the route node, and it will be reached to the route node, and it visits all the cities one by one. So let me take the example with a real time view. So traveling salesman problem, it's one of the optimization problem in artificial intelligence. We already know about it. So the problem it is given. So a salesman has a list of cities that must be visited exactly once. So the distance between every pair of a cities is known. The main objective of the shortest possible route that visits all the cities exactly once and returns to the starting city. So here there will be a 4 cities are there, mentioned as A, B, C and D. So distances between each and every cities. So A to B will be of 6, A to C will be of 5, B to D will be of 3, C to D will be of 4, A to D will be of 1, B to C will be of 2. So this is the goal, to find the route with the minimum total distance of it. So now apply the generate and test. First will be of generating the possible routes. So starting from the city A, it generates all the possible routes. So the first possible route will be of A tends to B tends to C tends to D. Second route will be of A tends to B tends to D tends to C. Third will be the solution will be of A tends to C tends to B tends to D. Next will be A tends to C tends to D tends to B. A tends to D tends to C tends to B. A tends to D tends to B tends to C. So these are all the possible solution which can be explained in the below the diagram of it, how we can traverse a path of it. Now the second step will be of testing the each and every route. So we already have calculated the total distance of each and every route. So A tends to B tends to C tends to D will be having of 13. A tends to B tends to D tends to C will be of 18. A tends to C tends to B tends to D will be of 11. A tends to C tends to D tends to B tends to, that will be of 18. A tends to D tends to C tends to B will be of 11. A tends to D tends to B tends to C will be of 13. So the tester computes that distance and checks whether it is smaller than the previously found routes. So next step will be of select the best solution among all these possible calculation with the solutions, uh, with the generated routes. A tends to C tends to B tends to D will be of 11. A tends to D tends to C tends to B will be of 11. These have the minimum path length. So the final solution for finding the traveling salesman problem for the minimum as well as shortest route has a cost of 11 units. So This is about it. First of all, the level 1 will be of choose the first city. Next, choose the next unvisited city. Choose another unvisited city. Continue until all the cities are visited. Each and every branch that can be represented with only one possible route. So the generate and test algorithm with the example of a traveling salesman problem explores these routes, calculate the cost and chooses the route with smaller cost. So generate will be all possible city arrangement that can be of routes. Test will be calculate the total distances of each and every route and compass them. Accept will be of choose the route with the minimum distances. So simple to understand and implement, that guarantees the finding the optimal route for the best path is the possibility or tested is an advantages. Disadvantages will be of number of possible routes grows quickly for n cities approximately n minus 1, which is not that is of routes will be of must be checked and becomes the impractical for large number of cities. So this is about it. And here the other one thing which can be represented with the lexicographical order. So lexicographical order is the same as in dictionary order. So cities are arranged in alphabetically, a less than b less than c less than d. So since the salesman starts from A, the remaining states will be of B, C, D, or arranged in a all possible permutation. So if you are just going to start with A, the routes will be of A tends to B, tends to C, D. Second step A, B, D, C, A, C, D, B, D, A, C, B, D, sorry, D, B, A, D, B, C, A, D, C, B. So how the routes can be shared and how it can be explained is that first of all it can be started with the routes that can be generated with routing start with A tends to B. So fix A tends to B and arrange the remaining cities C and D. A tends to B tends to C tends to D. That is one possible solution. A tends to B tends to D tends to C is an another solutions. Route starting with A tends to C. Fix A, C and arrange the remaining cities B and D. So A tends to C tends to B tends to D and A tends to C tends to D tends to B. Routes starting with A and D will be of fix A and D and arrange the remaining cities B and C. A tends to B, D tends to B tends to C, A tends to D tends to C tends to B. So which one will be having a fixed routes that will be of fixed. So totally there will be of 6 possible routes according to the permutation. Finally, we are just going to create with the lexicographical order and calculate the total distance for each and every route and find the selected the shortest and minimum distance of each and every route and calculate the distance for it. So this is about it, and finally we are just going to find the which is having the minimum value. That minimum value will be of 11. So which we got with the two solutions, that will be the final answer for it, and it can be used to generate all possible solutions before testing, and it is also used to find the optimal route for it. So now we'll be seeing about best first search. So best first search is an informed search algorithm. So that can be used with a heuristic function. So determine the promising node to explore next. So it will be followed the concept of priority queue and heuristic search. So instead of exploring all the node level by level breadth first search and going into the depth like a depth first search, so that will be appears to be the closest to the goal. So it will be of a combination of DFS and BFS. So the main objective of best first search is to find a path from the initial state to the goal state which can be efficiently as possible. So to achieve this, the algorithm uses heuristic value h of n, which estimates the distance as cost the current node to the goal node. So the main principle for BFS will be of there will be of two different types of list are there. One is open list, that is priority queue, and another will be of closed list. So the main place will be of it will be started with the node in the open list. Select the node with the lowest heuristic value. If the selected node is in the goal node, stop the search. Otherwise, expand the node and generate in successors. Calculate the heuristic value of each and every successor. Insert the successors into the open list according to the priority. Move the expanded node to the closed list. Repeat the process until the goal is reached. Remain. So heuristic function that can be represented as h of n, that can be of estimated cost from node n to the goal. So the smaller than the heuristic value will be of more promising than the node is to be considered of it. So why we are just going to use of best first search, we can be called as an DFS and BFS. So like BFS, it keep tracks of each and every track and also generating the nodes and uses the queue structure. Whereas in DFS, it can move quickly towards the promising depth path without exploring all the nodes at the same depth. So that is why we are just going to combine the both the BFS and DFS approaches while using the heuristic information to guide and reach the possible solution in a best way. So that is why we are just going to have the combination of BFS and DFS. Moving to the advantages, so there will be of having a heuristic knowledge to guide the search. So often reaches the goal faster than the uninformed search methods, reduces the number of nodes explored, and suitable for pathfinding and optimization problem. So disadvantages will be of so it will be depends on performance heavily on the quality of heuristic search, may not always find the optimal solution, can consume large amounts of memory because all generated nodes are stored. So an incorrect heuristic may lead the search away from the optimal path, and the applications will be routing network, game playing, artificial intelligence, problem solving, especially of scheduling, which will be used in the best first search. So next to it, OR graph. So OR graph, which will be used in a best first search. So there will be of open list as well as closed list are the important heuristic algorithm searching that can be used in the BFS. So R graph is a graphical representation, so in which can be solved by choosing one of the several possible paths from the each and every node. At each and every node, the algorithm selects the most promising successor based on the heuristic value, so which helps avoiding revisiting the same node repeatedly. Easy to store the information about the explored path, and it is also used to keep track at the best route to the goal. Propagate the updated cost information whenever it is necessary. So information stored in each and every node of it. So first is description of the state. So it represents the current problem state. So current city for finding the route, finding the problem. So current board configuration in a puzzle. Indications of how promising it is. So this is heuristic value of h of n. It estimates how close the node is in the goal. So h of a tends to h of a equal to 10, b tends to h of b equal to 5, c tends to h of c equal to 2. So c is considering the most promising solutions where because the heuristic value is smaller compared to other values. So next will be of parent link. So it stores the node from which the current node is actually reached. A tends to b tends to c. So moving to that list of generated nodes. So it stores all the successor node generating from the current node. So A will be traversed with B, C and D. So why we are just going with OR graph, which can be used in BFS. So the algorithm mostly repeated visiting the same nodes, leading to increased in computation time, increased in the storage memory, and it will be having a infinite loops in the cyclic groups. So why open list? There will be of two different types of list are there, open list and closed list. Open list. So open list that can be contains the nodes, so that can be have been generated, so have heuristic values calculated, have not been expanded or examined. So it can be acts like an priority queue of it. So purpose will be of stores the candidate nodes, selects the best node or expansion, guides the search towards the goal. The closed list will be contains the node that have already been expanded and examined. So the prevents the revisiting the same node, avoids cycle in the graph, improves the efficiency, reduce the redundant computations. So this is about the difference between them. So next we'll be seeing about the or graph with open and closed with algorithm searching technique. So already we know about it. So open list, it contains the node that have been generated but not to be examined. Closed list will be contains the nodes that is already been examined. So this can be maintained with the priority queue, and the nodes are ordered according to their evaluation functions. Open and closed function, that will be of open stores the node first point, um, open stores the node waiting to be explored. Closed stores already the node exists explored. Second step will be initialize the insertion. The insert the initial node. So starts from the initial node, we can take it as an A and place it in the open list. Open of A, then close will be empty. Since A is a starting node, it will be a first candidate for the exploration. Check whether the open is empty. Before selecting a node, check whether open contains my node. If open equal to open and close parenthesis, return false. If an open becomes empty, it means there is no more nodes to explore and the goal cannot be reached. Fourth one will be select the best node. Remove the first node from open and place it in closed. Open equal to B C D, select B. Open of C and D, closed of B. The selected node is usually the one which is having the lowest evaluation value and also stored in the parent information for the final solution path that can be reconstructed later. And final point will be of final step, check for the goal node. If the selected node is in the goal node, if we can check it, n equal to goal returns true, move it to the closer and stop the search. The solution path can be obtained by following the parent link backward. So ACF, that will be of goal achieved, and if it is of going with the backtracking, the goal is achieved. So finally the sixth one will be of expanding the node. If the selected node is not in the goal, generate all its immediate successor and calculate the evaluation function for each and every node. So once if it is goal is not found, so we'll be continue with the same procedure, like select the best node, move it to the closer, test whether it is the goal, expand it to necessary, reorder the open, repeat until the goal is found or open becomes empty. So that is an good example for it. And here we'll be using of that is of evaluation function f of n. So the evaluation function measures how promising the node is for the greedy best first search. F of n equal to h of n. H of n will be of estimated distance for each and every node to the goal. So f of n is an evaluation function, the node which will be used to find the smallest value in the selected first. So the time complexity, it has been mentioned with big O of n log n. So inserting a node is an big O of log n. Removing the best node will be of big O of non n. So generally it can be of efficient than uninformed search, because it is uses the heuristic information to guide the search towards the goal of it. So next will be of heuristic function. So we already see about BFS and R graph, and now we are just going to see about the heuristic function. So heuristic function that can be represented in the short form of h of n is a technique which can be used in a artificial intelligence. So why we are just going for heuristic function? To estimate how close a current state or a node is to be in the goal state. It acts as a shortcut that helps the searching algorithm finds the solutions more quickly by making educated guesses instead of exploring every possible path. So whenever we are finding the exact solution is difficult, time consuming or computationally expensive, heuristic function provide approximate information that guides the search towards the promising direction. So the heuristic function that can be defined as h of n equal to estimated cost from the node n to the goal node. So n is the current node and h of n is the estimated distance for each and every cost to reach the goal of it. So there are two important characteristics that can be used with the heuristic function. One is admissibility, second one is consistency. Admissibility, the heuristic function is said to be as an admissible if never overestimates the actual minimum cost required to reach the goal. Mathematically, it can be represented as an h of n less than equal to h star of n. Whereas h of n, it can be represented as an estimated cost. H of n, the whole star, which can be of actual minimization of cost to reach the goal, is it. So which is can be used in a Google Maps. Next will be of an consistency, which can be represented as an monotonicity. So heuristic is consistent if the estimated cost from the current node to the goal is already less than or equal to the cost of reaching a neighboring node plus the estimated cost from the neighbor to the goal. H of n less than equal to C of n comma n dash plus h of n dash. H of n, which will be of heuristic value of the current node. H of n dash is an heuristic value of a neighboring node. C of n comma n dash is an actual cost of a n to n dash. So this is about it. Why consistency when is important? So prevents an unnecessary revisits of each and every nodes, and which can be used for searching more efficient and guarantees the optimality in A star search, and simplifies the implementation. So now we'll be moving to the greedy best first search. So greedy best first search is an informed search algorithm that chooses the node to be appear for the goal according to the heuristic function. So the term greedy means the algorithm makes the locally best solution or best choice for each and every step, hoping it will lead to the overall best solutions. So it is very similar to BFS. So whenever the BFS uses only the heuristic function h of n to select, it is said to be as an greedy best first search. So now here we'll be using the concept of f of n equal to h star of n, h of n. So h of n we already know, estimated cost from the node n to the goal. F of n will be of evaluation function used for the selected node. So the basic working principle for a greedy best first search that can be of, it will be starts with the initial node, place the node in an open list, select the node with the smallest heuristic value, check whether the goal state. If the goal is reached, stop the search. Otherwise, expand the node and generate its successors. Insert the successors into the open list. Repeat the process until the goal is achieved or not. So we'll be seeing the example for it. So finally, it will be of greedy search will be having the advantages of very simple and easy to implement, and will be a faster than uninformed search algorithms. Most heuristic knowledge to guide the search often reaches the goal quickly. So it does not guarantee the shortest path, may trapped in local optimized solution. Quality of the solution depends on the heuristic function, may ignore cheaper path because it considered as an estimated distance of the goal. So that is about it. So now we have been recollect the greedy best first search algorithm. It's an heuristic function that selecting the most promising node at each and every node, and it can be appears to the closest to the node and expand it first. So we already know about greedy. So it's an algorithm that will be having a best immediate choice without considering the overall path. So heuristic search that can be represented as an h of n. It's an h of n will be of estimated cost from the node to the goal. H of n value that indicates the nodes it is believed to the closer to the goal. So inform search we already know about it. It is information which is already known about it. The algorithm uses the knowledge about the problem that can be having the heuristic values. It is a combination of BFS and DFS which can be have the information about the direction likely to the goal. So using the priority queue. So the open is maintained to the priority queue. So open will be of having values, and the open will be of represented as some values. Finding the path from the start node to goal node. The objective is to find the route from the initial node to the goal state by repeatedly expanding the most promising node of it. By using of open and closed list, then it can be of generated having not to be expanded out. Selects the best node to each and every steps, and finally calculating the f of n equal to h of n equal to h star of n. So that can be represented of it, and we'll be having of next thing, the algorithm. So first there will be of having the two node list, open list, node is generated but not yet explored. Closed list, the nodes already explored. Now we'll be seeing the algorithm for the step by step procedure. First, place the starting node in the open list. Initially, we are inserting the starting node into the open list. So start node will be of A, open of equal to A, close will be of empty. Since A is an available node, it will be of selected first. Second step, check whether open list is empty. Before continuing, check whether any nodes left to the explore. If open equal to empty, return failure. If open list becomes empty, then the goal has to be found. There will be of no solution. Select next step will be of select the next step and best route. Remove the node having the smallest heuristic value h of n from the open list and place it to the closed list. So open, that will be of curly braces of b of some value, c of some value, and d of some value. Choose c of some value because it is having the lowest heuristic value. So this step will be ensures that the algorithm always expands the most promising node. Next step will be of expand the selected node. Generate all the immediate successor nodes of the selected node. So the newly generated nodes that are candidates for future exploration. Check whether any successor is the goal. After generating the successor, test each one. If successor equal to goal, return success, or else the solution path will be of obtained by tracing the links for each and every backward. Next step will be of evaluate the successor node. For each and every successor, calculate the heuristic value. So each and every heuristic value will be of having a value h of n, f of n or h of n less than equal to h star of n. So check the open and closed list. Check whether it is already exist in open. Check whether it is already exist in closed. This prevents the duplicate entries and repeated exploration. Return to step 2. So last will be of sort the open list according to the heuristic value. So now the algorithm returns to the step 2 and repeat the process again and again. So now we'll be seeing the example for it. So this is a diagrammatic representation of a thing and a table is given. So first we'll be having the heuristic value of h of n. So understand the graph. So we'll be having the value of s equal to 13. The node will be of s, h of n will be of 13. A will be of having the h of n value 12. B will be having the h of n value 4. C will be having of 7. D is having of 3. And E will be having of 8. F will be having of 2. H is valuing of 4. I will be of having 9. And finally, the goal state G will be of having 0. So the goal node will be of G in greedy best first search f of n or h of n equal to h star of n. So the node with the smallest heuristic value is always select from the open list. So now we will be seeing the step by step procedure. So now we can take it as an initialization the nodes. So open of first is we will be taking off open of first value is uh, that is of yes, open of yes. So now close will be of empty, that is of initializing the starting node. Now you are just going to expand the next step as yes, that will be of successor of yes. So a the heuristic value of 12 will be checking, heuristic value of 4 will be checking. So in this 4 is having the lesser value, move yes to closed. So open of a comma b, next value will be of closed of yes. So now according to the h of n, open of b comma a will be sorting out, since h of b equal to having the value of 4 less than h of a equal to 12. So now select b. So that now traversing path from s to b will be of having the value 4. Next is expand b. Now successor of b. Successor of b will be of e of h equal to 8. F of h equal to 2. So now move b to closed. So open of a comma e comma f. Close equal to 5 comma s comma b. So sort open. Open of f comma e comma a. So now we are just going to use the other step, open of a comma close of s comma b. So now we will be finding s tends to b equal to 4. So next step will be of again we will be traversing with the expanding the node. A will be having the two different types of nodes. So but a it is already having the highest value, we will be taking the B will be having the expanding node over here. So now B will be expanding with E and F. So now open of A comma E comma F, the close of S comma B. So open of A comma E. So why? Because A and E is having a highest value. So open of A comma E, close of S comma B comma F. So since S, B and F, it is having the shortest value, next we will be moving. So now the final step, open of A comma, now comparing with E and F, F is having the shortest value. Now we will be traveling and expand the value of E, sorry, F. So now F will be having the value of I and G. So open of A comma E comma I comma G, close of S comma B comma F. So now you are expanding the F value. F is having the two values. So 9 and 0 we are comparing. 9 is having the highest value. We are just going with the goal node 0 itself. Open of A comma E comma I, close of S comma B comma F comma G. So since we are just going to find the final path, the value will be of 4 plus 2 plus 0 equal to 6. So S tends to B tends to F tends to G. So that will be the finalist goal, and the root path which can be find the solution is the total cost is 6. Why greedy best first search we are using like this? We are just going to find the shortest path. So the properties that we are just going to consider for greedy best first search is time complexity B of M, big O of B of M, where B is a branching factor, M is the maximum depth of the each and every search tree. Space complexity will be of big O of B to the power of M, because all generated nodes may need to be stored in the memory. So there are some disadvantages are there, not complete always. Why? Because it may fail in the infinite searching spaces. So not optimal because it can be considered only the heuristic value and ignores the actual path cost. So finally, based on this particular example problem, we are just going to conclude the heuristic greedy best first search. So which will be having a heuristic value to guide the search. It repeatedly selects the root node from the lowest h of n value leading to the path, and finally we will be finding the solutions of from the root node as a parent S of a open list and closed list. Again we are just going to traverse and expanding the node. We are just going to conclude with S tends to B tends to F tends to G. So which is it is a optimal and shortest path which can be traversed from S to the starting node, that is a parent node, to the successor and to reach the goal node in the path of B, F and G. So this is the finalized conclusion of it, and which can be find the solution by following the most promising route towards the goal. So this is about the best first search and its example which can be comes under the informed search. So thank you.